Welcome to series of database management system video lectures. Today we'll be discussing about unit 3 topic 2, that is types of index. Now, with respect to file system organization mechanisms, we are going to understand two different types of indexing mechanisms which are going to be implemented on this file system organization. The first one is sequential file organization or ordered index file, which is also called as primary index. And the second one is hash file organization. As we have already discussed about what is indexing, how it is used, so let us discuss about the attributes of index. In the previous session, we have discussed the structure of the index, right? So we have few attributes or the properties which will define how an index can be created. The first one is access type, access time, insertion time, deletion time, and then space overhead. These are the attributes which helps us to understand how an indexing is being implemented. The first one is access type indicates that what type of indexing mechanism that we have used. So whether we have provided any attribute for searching. So a search key is a search key a prime attribute or a non-prime attribute. Prime attribute or non-prime attribute or a combination of attributes which are used, a range of attributes which are used to search for a given data with respect to the index. Now, access time. When a query is being processed by the database engine, how much amount of time is required for searching for the required data and access to the actual data at a physical location. This is the amount of time which gets involved for accessing to the required data is called as access time. Insertion time. This is the time which gets involved for searching for the required data and access to that physical address location and then insert the new data. The combination of all these times together is called as insertion time. The next, deletion time. The same thing, we need to search for the given data, access to that memory location, and then the amount which gets involved for deleting the specified record or the specified field. And then finally, space overhead. So this is the amount of space which is required in the index table. Now, as I already told you that index table is going to have only two columns of data. One is search key and the next one is data reference key. So as the number of entities which are enrolled in this index table and still how many more number of entities that are required to be kept in the index table, that amount of space which is required is called as space overhead. So these are the attributes for the index structure. With respect to the types of file organization mechanism, we have already discussed about what is sequential file organization technique in the previous video, right? Now, we have further classification of indexing techniques. The first one is primary indexing, secondary indexing, and clustering indexing. As part of primary indexing, it has been subclassified into dense indexing and then sparse indexing. Let us look at in detail about each and every one. The first one is dense indexing. In dense indexing, as the name itself tells, that huge amount of data. As we have already discussed that, we will have a separate data structure which is maintained for improving the performance of the database, that is called as index table, wherein we have the search key and then data reference. And the next one is main table, wherein the actual data will be stored, right? And this is the secondary storage area or the disk space. Now here, the memory is being subdivided into various blocks. This is block 1, this is block 2, and this is block 3. Assume that we have 4 blocks of data. First block starts with starts with 1000, 1, 2, 6. And second block starts at 1008, 10, 12. Third block starts from 14, 16, 18. Fourth block starts at 20, 22, 24. Right? Now let us take that this is our student table. In the student table, we have key attribute as student ID, student name, and their contact number. Only these are the fields that we have. Let us take this. Now, the student IDs are 5, 7, 2, 1, 8, 6. And the names are Arun, Bhaskar, Trisha, Megha, Ram, Kumar. These are the names. And the contact numbers, let us say that all starts with 9s, 8s, 9849, 9949, 8762, 7654. So here is the data which we have in our student table. Now, in block 1, the first few records are fetched. The first few records are fetched and stored into block 1. So this is placed here. And in block 2, the second set of data records are fetched and then placed into the block 2. Right? This is how we do. So the whole table contains 6 records. So in this index table, it maintains the information about all the 6 records. 572, 186. This in dense indexing, how many number of entries we have in this main table, all that entries are also maintained in this index table. So that huge the index table will be. So that's why the name is taken as dense index. Now the record 5 can be obtained from the physical location house. So this can be maintained here. And record 7 can be obtained from the memory location 1002. And record 2 can be obtained from this. And record 1 can be obtained at 8. And then this can be found from 10 and then 12. So this is how the memory address of the particular record can be fetched. And that's how it can be retrieved from here. So in this index table, the number of entries in the main table, the same number of entities, the same number of items can be reflected as part of index table. So that is about dense indexing, wherein the huge or the total number of records which are there in the main table are going to be reflected as part of index table. What can be the characteristics of this index of this dense index? In dense index, search keys may or may not be ordered. So it can function if the search keys are ordered also and unordered also. Now here in this case of our example, we have not ordered the records based upon the key attribute. So even though you will be able to retrieve the records information in an easiest manner. And then second point is that the data reference keys may not be ordered or unordered. Even this can also be accepted. Third point is that the search keys should always be unique. This is the important point to be noted. And then fourth point is that none of the search keys should be made it as null. As by default, primary key attribute should be given with any kind of value. It should not be left as empty. Right? So these are the features for the dense indexing table. And the advantages of this dense indexing is that very fastly we will be able to access to the record. Second point is that as the search keys are not, as the search keys are ordered, either ordered or unordered, you will be able to access to the data. We need not perform any kind of special treatment for performing this operation, right? Now, the drawbacks for this is that what can be the drawbacks for this dense indexing? The one of the biggest drawback of dense indexing is that in our physical memory, that is RAM memory, you should have lot of space for holding this index table, because index table is very huge such that it should accommodate all the number of entries from the main table. So we need to provide more amount of space in the RAM memory for allocating the index table structure. So that is one of the biggest drawback of this dense indexing. In order to overcome with this type of indexing mechanism, we have the next type of indexing, that is sparse index. Now let us look at the next one, that is sparse index. This indexing technique has been defined in such a way that, let us take the same example here, that is student table. Here we have the records which have been ordered in this manner. In sparse indexing, instead of putting all the records in the index table, what they will do is that they are going to reduce the size of the index table. Index table is reduced up to 50% of it. So here we will have search key and data reference key with only 50% of entries. Look at here, how many number we have? 1, 2, 3, 4, 5, 6. We have 6 records of information in this dense index table. When it comes to sparse index table, there must and should be only 50%. Half of the length or the size of the index table has been reduced. So we'll be maintaining only very few number of entities. Now, how that can be possible? Now, before we do that, we need to apply a sorting mechanism here. We need to sort this particular content of data, that is student ID, which is a key attribute. We need to sort this table so that the first record will be 1 mega. Records are going to be sorted. Then 2, fifth record, 6, 7, 8. Okay, 6 is for Kumar, 7 is for Master, and 8 is for Ram. This is how the records are going to be sorted based upon the key attribute in an ascending order. Right? Now, the entries are maintained in the sparse index table in this manner. We will just store only one record. We'll give the information about the first record and then its reference key value, data reference key value. So this can be maintained in block 1. And this can be stored in block 2. And block 1 starts from 1000, 1001, 1002. And this can be obtained from 1003, 1004, 1005. Right? So now 1 can be obtained at location 1000. So let us update that in our sparse index table at 1000. Now, the next is that the first entry is made in the sparse index table. Now let us look at the next one. That is the second block. In the second block, we have the records which begins from 6, SID 6. So it maintains the 6 and the addresses for 6 is 1003. So it just refers to only the record which has 1000. Okay. And this refers to the record which starts from, this is for block 1 and this is for block 2. Okay. So in this manner, what happens is the first block or first entry is updated in the index table. Second block, first record is updated in the index table. So that is how we have drastically reduced the total size of the index table to be much more smaller compared to the dense index table. Right? So this is how you will be able to fetch the data at a very fastest speed. And then second, the characteristics of sparse index table is that the search key should always be ordered. Without ordering this, you cannot perform this sparse indexing. The second one is that always the search key should have unique values and it should not be not null as well. Right? And the third point is that one search key can be used. Once one of the search key of one particular block is obtained, it has to navigate through all the records which are there in that block. Only after searching for that and the retrieved or the required data is obtained, only that record can be fetched back into our RAM memory. So only one disk operation we are going to perform there. So the advantage is that 3/4 of the disk IO operations have been reduced with the help of this sparse indexing technique. And the advantages of the sparse indexing technique is that it can fetch the data at a rapid speed. And the second one is that as it is ordered, a lot of time gets reduced for search as well as for accessing it. And third important point is that a very less amount of physical memory is being allotted for the index table for sparse index. So these can be taken as the advantages, and the drawbacks is that we need to handle the data, the original data in a specialized manner. So we need to convert all the unordered data into the ordered data. So this mechanism either should be implemented while storing the data into the database, or once the data is stored or inserted in the database, later we need to apply the functionalities to sort it in the order. So this is the special mechanism that we need to do as part of the developer. Only then we will be able to achieve the sparse indexing mechanism, right? Now the next one is hash file organization technique. So in this file organization technique, we use different types of indexing mechanisms that can be helpful for fetching the data without compromising the performance of the database management system. Now, let us look at here. So hash file indexing organization technique can employ two types of indexing techniques, that is secondary and then clustering technique. Secondary and clustering technique. Let us look at this with an example. Now let us take the same example which we have used for the beginning part of the indexing technique, the employee table, which contains employee ID, name, job name, manager, hire date, salary, commission, and then department type. Now, how do this table can be used for indexing with the hash file organization technique? In hash file organization technique, we will see that the index table is created in such a way so that it will have a search key and then data reference keys. And this key can be used to fetch to these are the various blocks in secondary storage area, right? So now this is one. Now in block one, let us assume that there is a space provided for storing only 2 records of information. And then the similar kind of data, that is with student ID number as 100, we have some other connected information related to 100. So instead of maintaining a separate table, I need to provide another data pointer which will refer to the other set of record information. So which means that the whole amount of data can be evenly distributed across the whole table, across the whole memory location. So here we are going to apply hash function in the background. Hash function is used for generating the actual address. So these data items are going to be maintained in such a way that every individual data item can be referenced with the help of buckets, so that the related information can be maintained in various buckets. This is bucket 1 and this is bucket 2. And the second record information is also maintained in another interconnected buckets. So this will have a vertical extension of the data. Earlier, we just saw the index table to be extended in a horizontal manner. Either the index table has been increased in a horizontal manner, wherein the total size of the index table is going to be increased to a larger extent. And the main table, which contains all the data items, will also be large enough to fit this data into the secondary storage area. So in that case, I need to rotate the data and store it in such a way that all the connected information or the relevant related information can be obtained with the help of this buckets. So we will use the hashing mechanism for retrieving the data of the related data items in this manner. So in this hash file organization technique, we have other 2 types of techniques. One is clustering indexing. The second is secondary indexing, or which can also be termed as a 2-level indexing technique, which is also called as 2-level indexing technique. And the third one is dynamic or multi-level indexing technique. multi-level indexing technique. So these are the three types, subcategories under hash file organization technique. So let us get deep dive into each and every individual technique. The first one is clustering index. To understand this clustering indexing, let us look at this employee table. Look at this employee table. With respect to job names and manager ID, you can decompose this large table into smaller subtables. How that can be done? Now, identify the duplications here. We found that president is one particular entity, that one particular item which has not repeated. And the second one is manager. Manager has been repeated for twice. And the third one is salesman. Fourth is clerk. Fifth is analyst. Yeah, clerk also do comes here for this. Okay. Now, this large table can be broken down into smaller subtable in this manner. So here we have clustered index table to be developed in this manner. Search key and then data reference key. In the search key, we specify the employee ID number as it is a primary key. And then all the related information of manager ID and then all the connected information is data reference. So here search key can be taken as the manager ID, that is 68319. Okay. This can be obtained at a memory location 2000. This can be found at memory location 2000. Now the manager ID is a 68319. All the connected information about the first, here you will have employee ID information. Okay. We will have another table. That is employee ID number, then its attributes. So employee ID number is of 68319. So from this, the data reference key will maintain the address of this particular record. So only one entry for the manager is maintained here. All the manager ID of 68319 can be maintained in this table. So all the related data records can be maintained in one particular table. So that's how it can be called as one cluster, manager cluster. There is another cluster which is going to be maintained, cluster table, wherein it gets pointed to here. The second one is 66928, which is referring to sales cluster. This is manager cluster and this is sales cluster. Similarly, the sales cluster detailed information can be retrieved from the other interconnected table, right? And the third entry in this cluster index table would be clerk. So the clerk information that is 67858. 67858 is the ID of the clerk. So we will have another cluster which will have for clerk. This is a cluster related data records of the clerk can be maintained here, which can interconnect to the other table, right? So this is how the cluster indexing can be made. The cluster information, the first entry of this particular cluster is maintained in this cluster tables. And the second cluster group first entry is maintained here. So that's how the clustering indexing will have the characteristics to be. Cluster index table will have the search keys to be unique, not repeated, and then which cannot be null. And then these are the characteristics of the search key. Now, cluster can be formed either by taking only one particular attribute or a combination of attribute choices up to us, right? Now, what can be the advantages of this cluster indexing and then drawbacks? For the advantages is that all the similar data records can be grouped together. This will improve a lot of search and then access time, right? With a very short amount of time, the users are responded. The second one is that this is easiest one. More number of disk and then IO cycles gets reduced or also reduced. When it comes to the drawbacks, we need to have a special mechanism for handling this cluster index because we need to group all these data records and then we need to sort it out, group it so that all the relevant data can be kept put into another table. We need to create a more number of tables which have been decomposed to a smaller subtables. That is a special mechanism that have to be applied, right? So that will be overhead for time as well as for space. So this is about cluster indexing. And the second one is secondary or two-level index. Here in this two-level indexing, look at here. In two-level indexing, we will have index table, that is primary index table, wherein it will have the information about search key and data reference keys to be like this: 101, 201. So the first record can be obtained at memory location 1000. The 101 record can be obtained from memory location 2000, and the third entity information can be retrieved from 3000. So in two-level indexing mechanism, we will have another index table wherein this will also have search key as well as data reference keys for numbering from, this is 1000, numbering from 1 to 100 key. Okay. Now the first record information can be fetched from the memory location 100. Okay. So this again points to another index table. So the first record can be fetched at memory location. This is at memory location 100. So here, this is 1 to 10. Let us take this as 1 to 10. So the first record can be obtained at memory location 10. Okay. So two-level, you can understand this to be a two-level as well as a multi-level. When only two index tables are used, then it is called as two-level indexing structure. When multiple number of more than two indexing tables are used, then it is called as multi-level indexing structure. Now record with the primary key 1 can be fetched at memory location 10. Now here actually we find the information about the record. So this is employee ID 1 and the name is ARC, their contact details and everything can be retrieved from this. So as we have used index table 1, index table 2, as well as 3, then it is called as multi-level indexing structure. If we have used only 2, then it is called as two-level indexing structure. So why this sort of technique that is being implemented? This reduces putting all the data together, making a very large or dense table, dense index table or large table of information, wherein reading and then searching for the data will be a tedious job. Instead, when you break down the whole table of information into multiple smaller subtables, fetching the data and then accessing to it, searching time will also get reduced to a greater extent. Right? So the characteristics of this secondary as well as multi-level indexing technique is that always the search keys should be unique with respect to one table. Okay. And then not null. And search key should definitely be representing with only one attribute of information, not more than that, unlike with the other kind of thing. Next, the advantages of this indexed cluster, advantages of two-level index table is that we are breaking down the large amount of data into smaller two subtables, and these two index table helps us in identifying the data in a better manner. Maintenance of this data could be easier as the data is going to be extended to a larger one, then maintenance of it becomes very easy. There will not be any problem in doing that. And access time, search time, disk IO operations, all are going to be reduced to a greater extent. And then drawbacks of it. Drawbacks are that we need to design the tables, multiple number of smaller subtables. Decomposition of these tables have to be done. And then wherein we need to perform denormalization of data so that you will be able to rearrange the data in such a way that query optimizer will be able to retrieve the information at a very fastest speed. So for doing this sort of thing, there will be a lot of overhead that gets involved with respect to space, time, and then the algorithms which gets implemented in the background for the arrangement of data. All these are the drawbacks of two-level as well as multi-level will have the same sort of. Now, another important point is that as the number of index tables are increasing, we need to fit all these index structures into the physical RAM memory. That is again the challenging task with respect to two-level or multi-level, whereas single-level or primary indexing table can be easily fitted into a RAM memory, whereas this again takes a lot of swap in and then swap out time, right? So this will be the end of types of indexing mechanics. Thank you.